Hi everyone! Today you're going to be learning about expectations for compound events. So we've talked about this word expectations before, trying to do a little bit of math and figure out what might happen, what's a good possibility. And then this word compound here just means more than one. So for example, instead of just flipping a coin once and then seeing heads or tails, you might flip that coin 3 times in a row, and then you'd have to figure out all the different combinations of outcomes that could happen with flipping that coin 3 times in a row. So I'll do an example with you using a spinner, and this spinner just has 2 parts, blue and red. So if we were going to figure out a probability for how many times we might land on blue or red, we can see that blue is 1 out of the 2 parts of the spinner, and the red is 1 out of 2 parts of the spinner. So we would say that landing on blue or red is equally likely. Okay, and the probability is about 1/2 for each. Although we know that in all of these experiments or games of chance, it comes down to luck, and you might get 1/2 and 1/2 or you might not. This is just a way to have a good guess, basically. An expectation is thinking about what most likely will happen, even if it might not. Okay, so here I have my compound event. I want to spin this spinner 3 times and figure out all the different combinations of outcomes that could happen. All right, so I'm going to walk you through kind of this tree-looking diagram that branches out that you're going to see in your book. And what we have to do first is we have to think about what could happen on spin 1. So on spin 1, I could land on blue or I could land on red. Okay, then after that, I'm going to now branch out from there. So let's just start with blue. So say I spun blue first. Then we have to think about what might happen on our second spin. Same with the red. If we land on red first, what could happen on the second spin? And the reason I'm putting 2 arrows there is because I only have 2 things that could happen on my second spin. I could land on blue or red. Okay, and same if I spun the red first, I could land on blue or red next. Okay, then for my third spin, so say I did blue first, then blue again, and now what might happen the third time? So again, you're using these little arrows to show what could happen next. So if I did blue first and red second, then what could be my outcomes next? And I'm putting 2 arrows coming out of each of these because again, I know that I can only land on those 2 things in my next spin. Okay, so I could land on blue first, blue second, and then blue third, again blue or red. Or I could go red. Or I could go blue, red, and then blue or red. I could go red, then blue or red here, and then red, red, and then blue or red here. So hopefully you're able to follow how I did that. Basically, I'm just thinking about what could happen each time I spin that spinner. And now I can put together all the different combinations that could happen. So here we go. The first thing that could happen is I could go blue, blue, blue. So blue, blue, blue is one of the outcomes. Then I could have gone blue, blue, red. And I'm just reading off this tree diagram. Blue, red, and then blue is my next possible outcome. Blue, red, red. So see if you can, I'm going to point as I go, see if you can follow this. So that's all the outcomes that could happen if I spun a blue first. Now if I spun the red first, I could have gone red, blue, blue. Or red, blue, red. Or red, red, blue. Or red, red, red. Okay, so there we go. through drawing this diagram, I was able to come up with every possible outcome for spinning that spinner 3 times. All right, so now that I can see all my outcomes, I can answer a few questions. So let's have a look here. I've written down a couple of questions that are similar to what you're going to see in your book. So it's going to ask you something like, how many different ways are there to get each result? And they'll give you a list of results. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 different outcomes that we could have gotten. How many of them are 3 blues? Well, only 1. So I'm going to put a 1 here. How many are 2 blues and a red? So I've got 2 blues and a red here, here, and here. So 3 are 2 blues and a red. How many for 2 red and 1 blue? 2 red and 1 blue. So that's 3 again. And then how many for 3 reds? And that's 1. Okay, so then it might ask you for this fraction, which is like our probability fraction. So turning these numbers now into fractions. So what fraction of the time would you expect to land on 3 blues? 1 out of, and then I have to get my total outcomes for 8, so that's your denominator. 1/8. For 2 blues and a red, that was 3 times out of 8. So what it's saying is if we spun the spinner 8 times, this is how many times we would expect to land on these. 2 blues and a red was also 3 out of 8 and 1 out of 8 for the 3 reds. So we would say that 3 blues and 3 reds are equally likely. You're equally likely to land on those two. And then 2 blues and 1 red is also equally likely to 2 reds and 1 blue. All right. So you've got your probability fractions here. Now let's say we play this game more than once. Then how will we write down our expectation? So for example, 3 blues, we know that that was 1/8. Okay, if we want to see how many times we would land on blue if we played this game 8 times, okay, then we would just read it as that, okay, because our denominator is 8. If we wanted to say maybe 16 times, then we would take that 1/8 and we would make it into equivalent fraction with 16 on the bottom. So we did this before for expectations, is changing that denominator, which means we'd be just multiplying, and 2/16 of the time we'd land on 3 blues. That's if we play it 16 times. Let's look at the 2 red and 1 blue. That fraction was 3 out of 8 times. If you want to play this game 32 times, just change that denominator to 32. I know I have to multiply by 4 here, and we would say that 12 times we would land on 2 reds and a blue. That's how many times we would expect to land on 2 reds and a blue if we played 32 times. All right, so using a bit of what you know to find expectations, and then reading and creating these diagrams so that you can come up with all the different outcomes today for compound events. So have fun doing that, everyone. Let me know if you have any questions.